A fisherman lifts a sliver of pufferfish to his lips, a delicacy he has eaten 100 times. First his lips go numb, then his tongue. Then, quietly, he discovers he cannot lift his arm, cannot fill his lungs, cannot make a sound. And here is the terrible part. His mind stays perfectly clear. He is awake inside a body that has stopped answering. He hears the room, he watches. He simply cannot move. The molecule is Tetrodotoxin, and it does one small, exquisite thing. It plugs the voltage-gated sodium channels that let your nerves fire. No sodium, no signal, no breath. Paralysis without sleep. Awareness without a voice. Hold that image, because tonight it opens onto stranger doors. Here is the first. You were taught that poisons and medicines are opposites, one column to fear, one to trust. That is not quite what is happening. They are, so often, the very same molecule. Botulinum toxin is the most potent substance known by weight, a lethal dose near a single nanogram per kilogram, and we inject a whisper of it into faces and call it Botox. Digitalis, wrung from the foxglove, has stopped hearts and steadied failing ones with the same hand. Atropine, drawn from deadly nightshade, kills and rides in every emergency crash cart on Earth. Poison and cure are not two things. They are one continuous scale, and the only variable is dose. The second door. 2 frogs and 2 fish, and the very same sodium channel undone 2 opposite ways. One poison jams the gate shut, one welds it open, and somehow both stop your heart by the same final silence. How can locking a door and breaking it off its hinges lead to the same room? And the third. Imagine breathing calmly, chest rising, air rich with oxygen, while every cell in your body is quietly suffocating. That is cyanide at cytochrome C oxidase, the last enzyme in the chain that turns oxygen into life. The air is there. Your cells simply can no longer use it. So let your shoulders drop, let your breath go long and unhurried. Lie still and let the night hold these molecules for you, one at a time. If you'd like, a soft like and subscribe before we begin, then we drift. So let your shoulders drop and let the day loosen its grip on your jaw and your hands. This is pharmasomnia, where we take the machinery of the body and slow it right down night after night until the science itself becomes something you can fall asleep to. If these slow journeys through your own chemistry bring you any rest at all, you might let the channel know with a like or a subscribe, and then we won't ask again and we won't raise our voice for the rest of the long night. From here on, we only wander, and we only explain, softly, the machinery underneath your skin. There is a sentence, nearly 500 years old now, that every toxicologist still carries like a small stone in the pocket. It was written by a restless Swiss physician who called himself Paracelsus, a man who burned the old textbooks in a public square and preferred the language of miners and alchemists to the Latin of the universities. What he wrote, stripped down, was this: sola dosis facit venenum. Only the dose makes the poison. And in the dark, with your breathing already beginning to lengthen, I want you to hold that sentence gently, because it is the spine of everything we will wander through, night after night, in this long catalogue of the ways a molecule can quiet a human body forever. Only the dose makes the poison, not the plant, not the serpent, not the pale mushroom pushing up through leaf litter in an autumn wood. The molecule is indifferent. It does what its shape allows it to do, at whatever concentration it happens to reach. Water, taken by the gallon fast enough, will dilute the sodium in your blood until your neurons misfire and swell. Oxygen, breathed at high pressure, becomes a seizure-inducing toxin. And the deadliest substances we know, the ones that fell emperors and filled the pages of 100 detective novels, become, at the right vanishing dose, the medicines lined up in a pharmacy. The line between remedy and ruin is not a wall, it is a number. And that number has a name. The number is called the LD50. Say it slowly to yourself as the room settles. The median lethal dose, the amount of a substance that, given to a population, would be expected to kill half of them. We write it as milligrams of poison per kilogram of body weight. because a dose that barely troubles an ox may stop a sparrow's heart, and your own mass is part of the arithmetic of your survival. A small LD50 means a fierce poison, a fraction of a milligram per kilogram, and you would need only the weight of a snowflake to cross the threshold. A large LD50 means the body can absorb a great deal before the machinery fails. This is the ruler we will carry through every chapter, laid quietly against each new molecule, not to frighten you, but to measure, the way a physician measures, with a steady hand and no raised voice. And here is the first choice I want to make with you, the shape of the whole journey. We could organize this catalogue the way a child organizes a bestiary, by the creature that carries the venom. The snakes here, the spiders there, the plants in their own quiet corner. But that is not how a pharmacologist sees the world, and it is not how we will drift through it. Because the cobra and the pufferfish and the humble potato sprout have nothing in common in their bodies, and yet they can kill you by the very same mechanism, by jamming the very same molecular lock. So we will organize the night not by who carries the molecule, but by how the molecule stops the machine, by the exact place it reaches inside you and the exact piece of you it silences. Let me lay out the ladder we will climb, rung by slow rung, so that even half asleep you know the shape of the descent. We will begin at the sodium channels, the tiny voltage-gated gates studded along every nerve, the pores that open to let a pulse of sodium ions flood inward and carry a signal down the line. Some poisons wedge these gates shut, and the signal simply never travels. Some wedge them open, and the nerve fires until it exhausts itself. From there, we move to acetylcholine, the messenger that tells your muscles to contract, and to the enzyme called acetylcholinesterase that is meant to sweep that messenger away, and to the poisons that let it pile up until every muscle locks. We will visit glycine, the quiet inhibitory break in your spinal cord, and what happens when the break is cut. We will visit the muscarinic receptors, where atropine and its cousins wander in and out. We will find the sodium-potassium pump, the tireless engine in every cell membrane that trades 3 sodium ions out for 2 potassium ions in again and again all your life, and the molecules that stop it dead. We will reach the ribosome, the factory that builds your proteins, and a toxin that shears it. And at the very bottom, in the deepest dark, we will find cytochrome C oxidase, the final enzyme in the chain that lets your cells breathe, and the metal-poisoned enzymes where a single stray atom slides into the wrong slot and the chemistry of life quietly seizes. That is the descent. Sodium channels, acetylcholine, glycine, muscarinic receptors, the sodium-potassium pump, the ribosome, cytochrome C oxidase, the poisoned metals. 8 rungs down into the machinery, and each one a different silence. But before we take the first step, we need a small vocabulary, a handful of words that will recur through every chapter like landmarks you pass again and again on a familiar road, so that hearing them will come to feel like coming home rather than learning something new. Let them wash over you now. There is no test at the end of this, only rest. The first is absorption. How the molecule crosses from the outside world into your blood. Through the wall of the stomach, through the lining of the lung, through a break in the skin, through the membrane under the tongue. A poison that cannot be absorbed is no poison at all. The death cap you swallow must first pass its toxin through the gut wall before it can find your liver. The second word is first-pass metabolism, and this one is beautiful in its quiet defiance. Blood leaving your gut does not go straight to your heart. It is routed first through the liver, the hepatic portal system, where an army of enzymes, the cytochrome P450 family chief among them, sets upon each foreign molecule and tries to break it down before it ever reaches the rest of you. This is why some poisons are deadly injected but nearly harmless. Swallowed, the liver disarms them on the first pass. And it is why others become more dangerous in the liver, transformed into something worse than what you took. The third word is half-life, the time it takes for the body to clear away half of whatever circulates within it. A short half-life means the danger flares and fades within hours. A long half-life means the molecule lingers for days, accumulating with each new dose, which is exactly how the slow poisoners of history did their patient work. A little arsenic in the morning broth, never enough to alarm, always enough to add to what had not yet left. The fourth idea is receptor affinity, how tightly a molecule grips the lock it was shaped to fit. Some poisons cling with a ferocity that ordinary chemistry cannot pry loose. They bind and do not let go. And the last pair, the pair we will lean on more than any other, agonist and antagonist. An agonist fits the receptor and turns it on, mimicking the body's own signal, pressing the key that was meant for another hand. An antagonist fits the receptor and turns nothing on. It simply occupies the seat, blocking the true messenger from ever arriving. Two opposite crimes at the very same door. Remember those two words above all. Agonist, the imposter who acts. Antagonist, the intruder who merely blocks. Now, and this is the thread I most want you to carry into the dark, poison has always been the quiet weapon, not the blade, not the fire, but the thing that leaves no wound, that hides in the wine and the porridge and the medicine bottle. Arsenic was called inheritance powder. In the courts of Renaissance Italy, tasteless and slow, so much a part of the machinery of ambition that entire families rose and fell on its account. It is the poison of Agatha Christie, of Sherlock Holmes, of the locked room mystery, because it kills from the inside with no fingerprints on the body. Until forensic chemistry learned to read the metal, it leaves lodged in the hair and the nails, and the quiet weapon began, at last, to speak. This is the forensic through line that runs beneath our whole catalogue. Every poison is also a story, and every story eventually meets the science that can name it. And here, as your thoughts begin to loosen, is the reversal I want to leave gently overturning in the back of your mind. The thing you may believe about poison that is not quite true. We imagine poisons as pure villains. They are not. The deadliest molecules we will meet are also, at the right vanishing dose, among the kindest medicines we possess. Consider botulinum toxin, the most lethal substance known to pharmacology, a protein so potent that a few hundred nanograms could kill you, a molecule that works by cleaving the very machinery that releases acetylcholine so that no muscle can be told to move. It is the cause of a paralysis that stops the breath, and it is also purified and diluted a millionfold, the substance we inject to still a trembling eyelid, to ease a clenching jaw, to smooth a frown, the same molecular knife wielded gently. Consider digitalis, drawn from the purple foxglove nodding in a cottage garden, a poison that stops the sodium-potassium pump in the heart, that at high dose sends the rhythm into fatal chaos. And yet at the right small dose, that very same interference makes a failing heart beat stronger and slower, and it has kept more people alive across the last 2 centuries than we can count. Consider atropine, from the deadly nightshade whose name, belladonna, means beautiful woman, for the drops that once widened the pupils of Venetian ladies into dark and fashionable pools. It is the antagonist that blocks the muscarinic receptors and can race the heart into ruin. And it is the antidote we reach for when someone is dying of the opposite poison, when acetylcholine has flooded every synapse and the body is drowning in its own signals. A double agent. A killer kept in the emergency drawer. Botulinum, digitalis, atropine, 3 poisons wearing the coats of physicians. Only the dose tells them apart, only the number on the ruler. So this is the spine of every night to come, restated once more as the room grows dim, not the creature, but the mechanism, not what carries the molecule, but where is it goes and what it stops. Sodium gate, the messenger, the brake, the pump, the factory, the final breath of the cell, and laid against each one, the quiet ruler, the dose that makes the poison, the number that stands between the medicine and the grave. We will descend that ladder slowly, 1 rung a night, in no hurry at all, because the machinery is vast, and the dark is long, and there is nothing here that needs solving tonight. For now, only let the words settle. Absorption, half-life, agonist, antagonist, dose. Let them drift down through you like sediment through still water, finding their level, asking nothing. Tomorrow, We begin at the sodium channels, at the gates along every nerve and the poisons that hold them shut. But that is for later. For now, there is only the sentence the old physician left us 5 centuries ago, glowing quietly in the dark. Only the dose makes the poison. Only the dose. Rest now. Begin, then, at the gate. Along every nerve you own, and stitched into the wall of every muscle fiber, there is a switch, a protein threaded through the fatty membrane of the cell, folded into the shape of a tunnel with a mouth that opens and closes. It is called the voltage-gated sodium channel, and pharmacologists write it as NAV, the little v for voltage, the Na for sodium, the metal of the sea that your body keeps in careful concentration outside each cell, waiting. When a neuron decides to fire, this is the door that swings. The membrane charge tips past a threshold, the channel's sensing arms shift, and the mouth of the tunnel opens for less than 1,000th of a second, and sodium, held in tension outside like water behind a locked gate, pours inward. That inward rush is the spark. It is the opening stroke of the action potential, the electrical pulse that runs the length of a nerve like a flame down a fuse. And every thought you have ever had, every heartbeat, every breath, began as a crowd of sodium ions falling through an open nav channel. So imagine, gently, what it would mean to cork that door, not to break the nerve, not to burn it, not to flood it, simply to place a plug in the mouth of the tunnel so precisely shaped that the sodium can no longer fall through. The wire stays whole, the battery stays charged. The command to fire arrives exactly as it always did, but the gate is jammed shut and nothing passes, and the flame never lights. There is a molecule in the world that does exactly this, and it lives inside one of the ocean's gentlest-looking creatures. Its name is Tetrodotoxin. It takes its name from the Tetrodontidae, the pufferfish family, and in Japan the pufferfish is fugu, the delicacy prepared by licensed chefs who train for years to trill away the organs where the poison concentrates. But here is the first quiet reversal. The fish does not make the poison, it borrows it. Tetrodotoxin is synthesized by symbiotic bacteria, species of Vibrio and Pseudomonas among them, living in and on the fish, and the pufferfish merely accumulates what its bacterial tenants produce, storing it in the liver, the ovaries, the skin. The same molecule turns up in the blue-ringed octopus, in certain newts, in a scattering of unrelated animals across the tree of life, all of them tapping the same microbial chemistry. The poison is older than any of its hosts. They are only the vessels. And what a shape it is! Tetrodotoxin is a small, rigid, cage-like molecule, and it carries a positively charged group called a guanidinium that fits into the outer mouth of the nav channel the way a key fits a lock, except this key does not turn the lock, it simply lodges in the doorway and will not leave. It binds at a site pharmacologists call Site 1, on the outer pore, the extracellular vestibule where sodium would normally begin its fall inward. The molecule sits there, physically occluding the channel, and the sodium current, the current the textbooks label INAR, drops towards zero. The nerve still tries, the membrane still reaches its threshold, the gate's own machinery still swings. But the throat of the channel is plugged, and no sodium comes, and no action potential forms. Follow the silence outward, slowly, the way it would actually move through a body. The sensory nerves go first because the smallest, most exposed fibers feel it soonest, and so the earliest sign is often a tingling, a numbness at the lips and the tongue, a strange, faint prickling in the fingertips as though the edges of the self were quietly dissolving. Then the motor nerves. The signals that tell muscles to contract depend, every one of them, on nav channels firing along the nerve and then again across the muscle membrane, and as tetrodotoxin corks those channels, the muscles simply stop answering. The limbs grow heavy, then unresponsive. Speech slurs and fades, the eyelids fall, and all of it climbs, muscle by muscle, toward the one that matters most. The diaphragm, the broad sheet of muscle beneath the lungs whose rhythmic contraction draws every breath you take. The diaphragm is muscle, and muscle needs its sodium channels, and when they are corked, the diaphragm goes still. The breathing stops, not because the lungs are damaged, not because the command to breathe has ceased. The brainstem is still sending the order, faithfully, into a line that no longer conducts. And here is the cruelty folded into the mechanism, the detail that makes tetrodotoxin one of the most quietly terrible molecules in nature. Consciousness does not depend, in any direct way, on the peripheral sodium channels the toxin reaches. Tetrodotoxin does not readily cross the blood-brain barrier at the doses that paralyze the body, and the awareness that lives in the brain does not need the corked channels to persist, so the mind can stay lit while the body goes dark. A person poisoned with tetrodotoxin may lie utterly paralyzed, unable to move an eye or draw a breath, and yet remain fully awake, aware, present, thinking, locked inside a silent body. It is paralysis without loss of awareness. The old accounts of the poison, the ones that gave rise to the zombie legends of the Caribbean, describe people declared dead and then recovering, and beneath the folklore is this precise pharmacology, a body switched off at the gates while the tenant inside remains at the window. Let that settle without alarm. We are only naming the mechanism. The gate jams shut, that is failure mode 1. Now bring in the toxin's twin, because it works the very same lock by a different hand. Its name is saxitoxin, and it comes not from a fish, but from the smallest drifting life in the sea. The dinoflagellates, single-celled organisms of the genus Alexandrium and its kin, the very ones that bloom in such numbers that they stain whole stretches of coastline the color of rust. A red tide. When these dinoflagellates bloom, the filter-feeding shellfish, the mussels, the clams, the scallops that draw seawater through their bodies to strain out food, take in the dinoflagellates and concentrate the saxitoxin in their tissues, holding it, hoarding it, until a single serving of shellfish can carry a lethal dose. This is paralytic shellfish poisoning, and it, too, is older and stranger than the creatures that carry it into us. Saxitoxin, like tetrodotoxin, carries guanidinium groups, 2 of them, and it binds to the same site, one on the outer pore of the nav channel, plugging the same throat, blocking the same inward fall of sodium. The molecular details differ, the poems rhyme. Where tetrodotoxin corks the channel with 1 cationic key, saxitoxin corks it with 2, and the potencies land in the same terrible neighborhood. The symptoms follow the same climbing path, numbness at the lips and tongue first, then the tingling spreading outward, then the weakness, then the paralysis rising toward the diaphragm. 2 molecules, 2 lineages of life, 1 lock. Both of them do nothing more than sit in the doorway and refuse to leave. And now the numbers, held out gently, the way you hold out something you want understood rather than feared. Pharmacologists measure lethal potency with a figure called the LD50, the dose that would prove fatal to half of a test population, scaled to body weight, and the lower the number, the more potent the poison. Tetrodotoxin's LD50 is on the order of a handful of micrograms per kilogram. A microgram is a millionth of a gram. To put that beside a poison everyone has heard of, cyanide, that byword for swift lethality, needs milligrams per kilogram to do its work, thousands of times more mass. By weight, tetrodotoxin is on the order of 1,000 times more potent than cyanide. Saxitoxin sits in the same range, one of the most potent non-protein poisons known. These are molecules that work not by flooding the body, but by fitting it, a few grains, precisely shaped, dropped into the right locks. There is no antidote. Let that be plain and quiet. No molecule has yet been found that pulls tetrodotoxin or saxitoxin out of the pore, no injection that reopens the corked gates. All that medicine can offer is to breathe for the body until the poison lets go on its own. Mechanical ventilation, a machine drawing air in and pushing it out through the still diaphragm, holding the oxygen steady while the toxin slowly unbinds and clears and the channels, one by one, come back to life. It is patience, mechanized. If the breathing is supported through the worst of it, the gates do eventually reopen, the sodium falls inward again, the nerves relight, and recovery can be complete. The molecule leaves the lock as cleanly as it entered, having broken nothing. Everything depends on keeping the body breathing across the hours when it cannot breathe itself. And one more detail, because it matters, and because it is the kind of thing that undoes a comforting assumption. Cooking does not save you. Heat destroys many poisons. It unfolds proteins, breaks apart delicate structures, renders the venom of a snake harmless if you were to swallow it. But Tetrodotoxin and saxitoxin are not proteins. They are small, rigid, heat-stable molecules, and they pass through the boiling pot and the hot pan untouched, arriving at the table exactly as potent as they left the sea. This is why the fugu chef trims and never cooks the danger away, and why a pot of steamed mussels from the wrong water in the wrong season carries its cargo intact. The fire that saves you from so much cannot touch these. So hold the whole shape of it now, softly, before we move on. 2 toxins, from bacteria and from blooming plankton, carried into us by a fish and a shellfish. 1 target, the voltage-gated sodium channel, the switch beneath every nerve impulse and every muscle contraction you have ever made. 1 action, a molecule lodged in the outer pore, corking the door so the sodium never falls, so the spark never lights, so the wire stays whole and utterly silent. The nerves go quiet, the muscles will not answer, the diaphragm stops. And the mind, needing none of these channels to stay lit, remains awake behind it all. There is no antidote but breath borrowed from a machine, and there is no cooking it away. This is the first of the poisons we will name across the long night. The gate jammed shut, the failure mode of the locked door. Remember its shape, because the body has many gates, and not all of them fail by closing. Some fail by refusing to close at all. That is where we will go next, into the poisons that jam the very same channels open, the exact mirror of tonight's molecules. But that is for later, further down into the dark. For now, only the locked gate, only the sodium held back behind a corked door, nav, the switch, tetrodotoxin, saxitoxin, the plugs, site 1, the outer pore, guanidinium, the key that will not turn. Let the words settle down through you, finding their level in the stillness, asking nothing. The gate is only a shape, and the shape is only a fact, and there is nothing here tonight that needs solving. Rest. We go on when you are ready, and not before. We go on now, gently, to the mirror. Because there is a second way to kill a sodium channel, and it is the exact opposite of the first. Remember the shape we left behind. Nav, the voltage-gated sodium channel, the fast switch threaded through every nerve and every beating fiber of the heart. Remember Tetrodotoxin. Remember saxitoxin. The guanidinium plugs that settled into site 1 on the outer lip of the pore and corked it, so that no sodium could pass, so that the switch could never be thrown, so that the wave of the nerve impulse simply had nowhere to travel, and the silence spread inward until the heart forgot how to beat. That was closure. That was the cork. Tonight we turn the molecule over and find its twin, and the twin does not close the gate at all. The twin holds it open, forever. Its name is Batrachotoxin, and it comes, of all things, from a frog no larger than the tip of your thumb, the golden poison frog and its cousins in the genus Philobates, small bright bodies moving through the leaf litter of the Colombian rainforest like drops of wet paint. Their skin is a warning, and the warning is honest. A single frog carries enough toxin to stop many human hearts. And here is the first quiet reversal to fold into the dark. The thing that is not quite what you were taught. The frog does not make the poison. It cannot. Raised in captivity, fed on harmless crickets, the golden poison frog grows up entirely non-toxic, harmless as a pebble. The venom is borrowed. In the wild, the frog eats small beetles, particularly beetles of the family Meliridae, and the beetles carry batrachotoxin, and the frog simply concentrates what it eats, storing the borrowed weapon in its skin. The poison is a supply chain. It passes from beetle to frog to fingertip, and only at the end of that chain does it meet a channel it can lock open. So let us follow it down to the channel, slowly, the way we followed the cork. Batrachotoxin is a steroidal alkaloid, a lipid-soluble molecule, and that fat solubility matters. Unlike the water-loving guanidinium plugs that sat on the outer mouth of the pore, batrachotoxin slips into the membrane itself, dissolving into the oily bilayer and approaching the sodium channel from within its own structure. It does not go to site 1. It goes to a different address entirely, a region called neurotoxin site 2, deep in the inner architecture of the channel, near the S6 segment of the channel's domains, the very helices that line the gate that is supposed to swing shut. And there it binds, and there it does the thing that makes it the perfect mirror of the toxins we have already met. It will not let the gate close. Understand what that means at the level of the single molecule of protein. A normal sodium channel is a machine of exquisite timing. Voltage rises, and in less than a millisecond the channel opens. Sodium comes flooding down its gradient into the cell, and then, almost instantly, a second gate, the inactivation gate, a little tethered loop of the protein, swings across the inner mouth and plugs it from inside, shutting the flow off within 1/1000th of a second so the membrane can reset, can repolarize, can be ready to fire again. Open, flood, close, reset. Open, flood, close, reset. That rhythm is the heartbeat. That rhythm is thought. Batrachotoxin binds and, molecule by molecule, disables the closing. It holds the activation gate open, and it prevents the inactivation gate from shutting, and it even shifts the voltage at which the channel opens, so that channels spring open at rest, at voltages where they should be silent. The gate that should flicker for a millisecond and shut now stands open, and it stays open. And sodium, which should enter in a brief controlled pulse, now pours in ceaselessly, a door propped wide with the tide running through it, and no one left to close it. Feel the difference, resting there in the dark. Tetrodotoxin corked the pore so nothing could enter. Batrachotoxin welds the pore open so everything enters and never stops. One is a wall, one is a flood. And this is the refrain to carry down with you tonight, the line to let echo as you drift. The same channel, opened or closed, ends the same way. Because it does. Follow the flood forward. When sodium pours endlessly into a nerve or a muscle cell, the membrane cannot repolarize. It cannot climb back to its negative resting voltage, because the very ions that make it positive are still streaming in through a gate that will not shut. The cell depolarizes and stays depolarized. And a cell stuck in that state does something first that looks almost like life amplified. It fires and fires again, uncontrollably, nerves discharging in storms, muscles twitching and contracting without command, because the threshold for firing is being crossed over and over by channels that are simply always open. There is a cruel brightness to it, a nervous system overrun with its own signal. But a channel held open cannot reset, and a cell that cannot reset cannot fire cleanly again, and soon the storm collapses into a different kind of silence. Depolarization block, the membrane frozen so far from rest that no coherent impulse can form at all. The nerve that screamed goes mute, the muscle that seized goes slack. Paralysis follows, and it climbs, the same slow tide we traced with the cork, until it reaches the muscles that draw breath. And the heart. Always, with the sodium channel, we return to the heart. The heart is a tissue that lives and dies by the timing of its sodium channels, and batrachotoxin ruins timing above all else. Cardiac cells depolarized and unable to reset lose the orderly march of the electrical wave that sweeps across the chambers and squeezes them in sequence. Instead, you get chaos. Extra beats, runs of tachycardia, and finally fibrillation, the muscle of the heart quivering in 1,000 unsynchronized directions at once, each region firing in its own jammed open channels, none of them agreeing, no pulse leaving the chest at all. A fibrillating heart is a heart full of motion and empty of purpose. It is working furiously and pumping nothing. And so, batrachotoxin arrives at the same destination the cork arrived at by the opposite road, a stopped circulation, a stilled body. One channel corked, one channel welded open, and between them the same dead silence. The same channel, opened or closed, ends the same way. There is no practical antidote. Let that fact rest lightly, without alarm, the way we let the others rest. There is no molecule kept on a shelf that reliably pries batrachotoxin back out of the channel and lets the gate close again. The binding is tenacious. The toxin is fantastically potent, active at doses measured in micrograms, among the most lethal small molecules known, comparable in its way to the corking toxins we have already met. And once it has diffused into the membrane and found its site, there is no simple key to reverse it. Some interventions can raise the sodium the channel must compete against. Some can blunt the arrhythmia, but nothing truly undoes the lock. The gate, once welded, tends to stay welded. That is the whole grim elegance of the thing. And yet, here is the turn that makes even this molecule strangely beautiful. The reason a scientist might hold it with something close to gratitude. Batrachotoxin, precisely because it locks the channel in one clean state, became one of the finest tools ever handed to the people who wanted to understand the sodium channel at all. A channel that flickers open and shut in 1,000th of a second is nearly impossible to study. It moves faster than most instruments can watch. But pin it open with batrachotoxin and suddenly it holds still. Suddenly the pore stays available, the gate stays fixed, and researchers can measure the current through a single channel for as long as they like, can map how ions move through it, can test which drugs still fit and which no longer do. Batrachotoxin became a molecular clamp for holding the gate open while human curiosity looked inside. It helped map Site 2, helped reveal how the S6 helices form the gate, helped illuminate the way local anesthetics and antiarrhythmic drugs, the lidocaines, the flecainides, the very medicines we use to calm a racing heart, reach in and bind the inner pore. The frogs borrowed poison, the beetle's chemical warning became a lantern for reading the structure of the switch that runs our nerves. A killer turned patiently into a key. So rest now, and let the ladder reform beneath you, rung by rung, as we have built it. At the top, the switch itself. NAV, the voltage-gated sodium channel, the fast gate threaded through every nerve and every beating fiber of the heart, opening and flooding and closing and resetting, over and over, a rhythm as old as animals. Then, the first rung down, the corks. Tetrodotoxin, saxitoxin, the guanidinium plugs that settle into Site 1 on the outer lip of the pore and stop the flow so nothing enters, so the switch is never thrown, so the wave of the impulse has nowhere to travel and the silence climbs inward. And now the second rung, the mirror rung, complete, batrachotoxin from the golden poison frog, born in a beetle, dissolving into the membrane, binding Site 2 deep in the channel's inner structure, holding the gate open so sodium floods in, ceaselessly so the membrane can never repolarize, so cells fire into storms and then collapse into stillness, so the heart quivers itself empty. Two toxins, two sites, two opposite molecular actions, one that corks the pore, one that welds it open, converging on the same failed channel, the same stopped heart, the wall and the flood, the gate that will not open and the gate that will not close. The same channel, opened or closed, ends the same way. There is a quiet symmetry in that, the kind the body is full of if you look, and tonight you do not need to look hard, or to hold any of it, or to solve a single thing. The frog is small and bright and moving through the leaf litter far away. The beetle it ate is smaller still. The channel is a shape, and the shape is a rhythm, and the rhythm, open, flood, close, reset, is running softly in you right now, in every nerve, in the muscle that is beating slow and steady beneath your ribs, closing its gates 1,000 times a second without your ever asking, without your ever needing to know. Let it keep its rhythm. Let the words find their level and lie still. We have mapped the sodium channel now, both of its ways to fail, and there is nothing here that asks anything of you. We will go on when you are ready, and not before, to other channels, other gates, for the sodium channel is only the first door in a long, dark, quiet house. But that is for later, further down. For now, only the two toxins, resting side by side, the cork and the weld, rest. In the last chapter, the message never left the nerve at all. Botulinum toxin slipped inside the ending and cut the wires before a single word of acetylcholine could be spoken. Tonight we cross to the far side of that same silent junction. We move from the mouth that has been sewn shut to the ear that has been stopped, and we find, waiting in the sap of a South American vine, a poison that lets the nerve shout as loudly as it likes because the muscle has simply stopped listening. Let your breath fall long and slow and follow the arrow. There is a plant that grows in the wet green shade of the Amazon, a woody climbing vine called Tetrodotoxin tomentosum, and from its bark the forest peoples of the Orinoco and the Amazon basins learned to brew a dark, sticky resin. They painted it onto the tips of blowgun darts and arrows. A monkey struck in the canopy would not fall in agony. It would simply, gradually cease to hold on. The limbs would loosen, the grip would open, and the animal would drift down out of the branches as though it had decided, mid-thought, to let go of the world. The poison had a name that travelled back to Europe in the mouths of explorers. Curare, from a word meaning, roughly, it kills birds. And the molecule inside it, the one chemists eventually pulled free and named, is ASD. Tubocurarine, a large, rigid alkaloid built around two positively charged nitrogen atoms held a precise distance apart. That distance is the whole story. Because the muscle end plate, the little patch of muscle membrane that sits beneath a motor nerve ending, is studded with a receptor whose lock was cut to exactly that shape. Recall the junction as we left it. When a nerve fires, it releases acetylcholine into the narrow cleft, and that acetylcholine drifts across and binds to the nicotinic acetylcholine receptor on the muscle side. This receptor is not a passive doorbell. It is an ion channel that gates itself. It is built of 5 protein subunits arranged in a ring around a central pore, and 2 of those subunits, the 2 alpha subunits, each carry a binding pocket shaped for acetylcholine. When acetylcholine settles into both of those pockets, the whole 5-part ring twists, the central pore springs open, and sodium ions pour inward. That inrush is the muscle's yes. It depolarizes the end plate, the depolarization spreads, and the fiber contracts. Every voluntary movement you have ever made, the turning of this page in your mind, the slow blink of your eyes right now, was a wave of acetylcholine opening those channels, muscle by muscle, and being heard. Curare is the guest who arrives first and takes the seat and then does nothing. Tubocurarine's 2 charged nitrogens fit the 2 alpha pockets almost as well as acetylcholine itself. It slides into the binding site and it sits there, but it does not twist the ring. It does not open the pore. It is a C-competitive antagonist. Competitive because it competes with the natural messenger for the very same seat. Antagonist because, having taken the seat, it produces none of the effect. The nerve, meanwhile, is entirely unharmed. It fires perfectly. It releases its packets of acetylcholine faithfully into the cleft. But the receptors are occupied, and the acetylcholine washes up against a door that is already blocked and finds no opening. The message is sent flawlessly and heard by no one. Here, then, are the 2 mirrored silences, and I want you to hold them side by side in the dark. Botulinum stops the signal from ever being sent. It destroys the machinery inside the nerve, the SNARE proteins that dock and release the vesicles, so no acetylcholine crosses the cleft at all. Curare lets the signal be sent perfectly and stops it from being heard. It caps the receptor so that the acetylcholine, released in full, arrives at a locked door. One poison gags the speaker, the other deafens the listener. And the muscle, which cannot tell the difference between an order never given and an order never received, does the only thing it can do in the absence of a command. It goes slack. It relaxes into flaccid paralysis, limp and unresisting, the same soft failure we watched in the botulinum chapter, arrived at from the opposite shore. And once again, this is the horror the calm forest resin conceals. The mind is untouched. The nicotinic receptors at the muscle end plate are a particular type, distinct from the receptors that carry thought and sensation in the brain, and tubocurarine, a large charged molecule, crosses poorly into the central nervous system. So consciousness remains. Sensation remains. In the early clinical decades, before this was understood, patients given Curare as a paralytic sometimes felt everything and could signal nothing, awake inside a body that had stopped answering. The poison does not dim the light in the room. It only cuts the wires between the mind and the hands. And it fails you in an order, the same grim procession every time, dictated by the sensitivity of each muscle group. Listen to the sequence the way you would listen to a tide going out. First, the small, fast, delicate muscles, the ones that move the eyes, and the eyelids begin to droop. Then the muscles of the face and the small muscles of the fingers and toes. Then the muscles of the neck and the limbs, the arms growing heavy, the legs unwilling. Then the muscles of the trunk. Then the muscles of speech and of swallowing. And last, always the final door to close. The diaphragm, the great sheet of muscle beneath the lungs whose rhythmic pull draws every breath you have ever taken. Every eyelid, every fingertip, every limb, every word, every swallow, and at the end, the breath itself. When the diaphragm can no longer hear the nerve that begs it to descend, the lungs stop filling, and a fully conscious person quietly suffocates in a body that has forgotten how to breathe. That is the arrow poison. And now the turn, because this same molecule, this deafener of muscles, became one of the gentlest and most controllable tools in all of medicine, and the reason lies entirely in the word competitive. Competition is a negotiation, not a demolition. Tubocurarine does not break the receptor, it merely occupies it, and it occupies it reversibly, binding, releasing, binding again in a restless equilibrium. And in any equilibrium of competitors for a single seat, the winner is decided by numbers. If you could flood the cleft with far more acetylcholine, the odds would tilt, with 1,000 molecules of the natural messenger crowding around each blocked receptor, the moment the tubocurarine slips off. As reversible binders always eventually do, an acetylcholine molecule is far more likely to reach the empty pocket first. Raise the concentration of the true key high enough, and you can simply outbid the poison for the lock. So how do you flood the cleft? You do not add more acetylcholine directly. You stop the enzyme that destroys it. In that narrow synaptic cleft sits an enzyme called acetylcholinesterase, whose entire job is to chop each molecule of acetylcholine apart within milliseconds of its release, clearing the door so the signal is crisp and brief. Give a drug that blocks that enzyme, an acetylcholinesterase such as neostigminest, and the acetylcholine that the nerve releases is no longer swept away. It lingers, it accumulates. It piles up in the cleft, molecule upon molecule, until its concentration climbs high enough to outcompete the tubocurarine and win back the receptors. The muscle begins, end plate by end plate, to hear again. The paralysis lifts. This is the antidote written into the poison's own mechanism, because curare only competus, it can be outcompeted, and neostigmine is the drug that tips the scale. And here is where the whole long story of these chapters coils back on itself, because this is the spine, restated in the sap of a vine. Dose and control turn arrow poison into the anesthetist's tool. In a surgical theatre, where a patient is already unconscious under a separate anesthetic and already breathing by a machine, the two great terrors of curare, the intact mind, the failing diaphragm, are answered before they can arise. The consciousness that would otherwise be trapped is switched off deliberately by other drugs. The breath that would otherwise fail is taken over by a ventilator, the machine descending and rising in place of the diaphragm. And what remains, once the terror is subtracted, is precisely the useful part, a body relaxed, still, its muscles quiet, the abdominal wall soft enough for a surgeon's hands, the vocal cord slack enough to slide a breathing tube between them. The forest's falling monkey poison, given in a measured dose to a patient who cannot fall and cannot suffocate, becomes only stillness, only rest. Modern anesthesia has largely retired tubercurin itself, with its tendency to release histamine and drop blood pressure, in favor of cleaner synthetic descendants. Forced blood anastracuroniums, forced racuraniums, tracuraniums, curturaniums. But every one of them is a child of the vine, and every one works by the same mechanism the Amazon discovered first. Sit in the nicotinic receptor, block acetylcholine, silence the muscle, and remain reversible enough that a rising tide of acetylcholine, summoned by neostigmine or by a newer agent, can. The arrow's tip and the surgeon's syringe hold the same idea, only the dose and the control around it decide whether it kills or it heals. So hold the two silences of these chapters together one last time before we move on, because they are the deepest lesson the neuromuscular junction has to teach. Botulinum unstrings the nerve, so no order is ever sent. Curare seals the muscle, so no order is ever received. The speaker gagged, the listener deafened. And in both, the message that fails is the same single molecule, acetylcholine, that ancient chemical, yes, and the muscle that falls silent, falls in the same soft, flaccid, unresisting way, and the mind above it stays lit, watching, until the last muscle, the great tireless sheet beneath the lungs, forgets the only rhythm that ever kept it alive. One poison teaches us how the signal is made, the other teaches us how it is heard. Between them, in that thousandth of an inch of fluid where the nerve almost touches the muscle, lies every voluntary motion of your life, and the terrible, beautiful precision with which a plant can interrupt it, and a physician can restore it, by adjusting nothing more than how many molecules stand at a door. Let that settle. Let your own diaphragm rise and fall, unhurried, unblocked, faithfully heard. And when you are ready, we will follow the poison further inward, past the muscle, past the nerve, to the very engine that keeps each cell alive. We have spent a long while now at that thousandth of an inch of fluid, watching poisons whisper at the doorway between nerve and muscle, botulinum silencing the signal before it can leave, Curare crowding the door so the message arrives and finds no one to receive it. Both endings arrive the same way. The muscle goes quiet, the breath goes still, death by too little. Tonight we cross to the opposite pole, to a poison that does not quiet anything at all, that instead tears the quiet away and leaves the body screaming in a language it cannot stop speaking. Its name is strychnine. Let me hold for a moment the picture you may already carry. The murder mysteries, the bitter white crystal folded into a glass of sherry, the villain in the drawing room. Strychnine has been the darling of detective fiction for over a century, and before that, the working poison of the rat catcher and the gamekeeper. It comes, most famously, from the seeds of Strychnos nux vomica, a tree of the Indian subcontinent whose flat, disc-shaped seeds are so bitter that bitterness itself seems to have been invented to describe them. Inside those seeds sit two closely related alkaloids, strychnine and its methylated cousin brucina. It is strychnine that concerns us. It is strychnine that does the terrible symmetrical thing. To understand it, we have to travel somewhere new, not to the neuromuscular junction out at the edge of the body, but inward, up the nerve, into the spinal cord itself, into the crowded switchboard of the brainstem, because strychnine does not act where curare acts. It acts where the body does its arithmetic. It acts on the brakes. Here is the fact the whole night turns on. Your nervous system is not built only to say, go. It is built, in almost equal measure, to say, stop. Every motor neuron in your spinal cord, every cell whose long fiber runs out to command a muscle to contract, sits bathed in a constant competing rain of signals. Some shout fire, some murmur, not yet, not so much, not now. Movement, real movement, the smooth turning of a wrist or the settling of your body deeper into the mattress beneath you, is not the shout alone. It is the shout and the murmur, balanced, negotiated, thousands of times a second in the dark of your cord. And the murmur, the not yet, has a molecule. Its name is glycine. Glycine is the simplest of the amino acids, a single carbon flanked by an amine and an acid, a molecule so plain you would never suspect it of holding your body still. But in the spinal cord and brainstem, glycine is the great inhibitory transmitter. When a small interneuron, a cell called a Renshaw cell, among others, releases glycine onto a motor neuron, the glycine drifts across the synapse and binds a receptor. The glycine receptor, a strychnine-sensitive channel built of 5 protein subunits arranged like staves around a central pore. And here we must be precise, because the mechanism is the whole meaning of the poison. That glycine receptor is a chloride channel. When glycine binds, the pore opens and negatively charged chloride ions flow inward into the neuron. That inward flow of negative charge makes the inside of the cell more negative. It hyperpolarizes the membrane, pushes it further from the threshold at which it would fire. In the calm accounting of pharmacology, glycine is an agonist at an inhibitory receptor. It binds, it opens the brake, the cell falls quiet, the muscle it commands stays still until it is truly, genuinely needed. Now imagine a molecule that fits into that same receptor, that settles into the site where glycine belongs, or very near it, and yet does nothing, opens no channel, passes no chloride, simply occupies the door, and by occupying it, keeps glycine locked out. That is strychnine. Strychnine is a competitive antagonist at the glycine receptor. Let that word sit. Antagonist. We have met agonists and antagonists at the neuromuscular junction, but here the arithmetic inverts, and the inversion is the cruelty. Curare was an antagonist at an excitatory receptor. It blocked the go signal, and the result was paralysis, silence, softness. Strychnine is an antagonist at an inhibitory receptor. It blocks the stop signal. And when you block a brake, the machine does not slow. The machine runs wild. This is the deep, elegant symmetry I want you to carry into sleep tonight. Blocking an accelerator and blocking a brake look, nothing alike from the outside, and yet both are simple acts of occupancy. A molecule sitting in a doorway, keeping the rightful messenger out. Curare occupies the door where go would be heard, and the body goes limp. Strychnine occupies the door where stop would be heard, and the body cannot stop. Flooring the accelerator and cutting the brake line produce the same runaway car. Antagonism at an inhibitory synapse is excitation. Removing a nose is indistinguishable to the trembling motor neuron from adding 1001 sex. So follow what happens in the cord, slowly, the way it happens. With glycine's inhibition removed, the motor neurons lose their governor. The murmur of not yet falls silent, not because the interneurons stop speaking, but because no one downstream can hear them. Strychnine has stopped the ears. And into that ungoverned silence pours every ordinary sensation, a sound, a touch, a shift of light against the eyelid. In the intact body, these inputs arrive, ripple through the cord, and are met at once by the balancing brake, sculpted into proportion. In the poisoned body, they arrive and find nothing to oppose them. A single sensory input, a hand laid gently on the arm, a door closing in another room, sweeps through the motor pools, unopposed, and detonates. Every muscle it can reach contracts at once. And crucially, muscles come in opposing pairs, flexors and extensors, the muscle that bends a joint and the muscle that straightens it, held, in health, in delicate reciprocal balance by exactly this spinal inhibition. Strip the inhibition, and both fire together, at maximum, at the same instant, the limbs do not move, they lock. This is the convulsion of strychnine, and it does not look like the convulsion you may picture. It is not the loose thrashing seizure of the brain in electrical storm. It is a tetanus, a rigid, sustained, whole-body contraction. The back arches until, in the old grim descriptions, only the crown of the head and the heels touch the ground. The physicians named this arch opisthetonos, the jaw clamps. The face pulls back into a fixed, ghastly grin the toxicologists called risus sardonicus way, the sardonic smile, a smile that is nothing but muscle, betraying nothing behind it. Every muscle, every flexor, every extensor, every fiber, the poisoned cord can command, hauling in the same direction at once, straining against itself, tearing at its own anchors. And here is the detail that ties this poison to the ones before it, and the detail I ask you to hold most gently of all. The site of the catastrophe is the spinal cord and the brainstem, not the cortex, not the seat of awareness. Strychnine, at the doses that kill, does not reach up and dim the lights of the mind. The person inside the arching body remains awake, aware, feeling each contraction as it comes, hearing the next sound approach, knowing it will trigger the next spasm, unable to speak, unable to soften, unable to stop. Consciousness, cruelly preserved, the same terrible signature we found in Curare, the same lucid witness locked inside a body that no longer answers. The end comes the same way it came at the neuromuscular junction, though it arrives by the opposite road. The diaphragm and the muscles of the chest wall are muscles like any others, and in the convulsion they too are seized, locked in contraction, unable to relax and let the chest fall, unable to cycle. Between spasms, if the poisoned body is left utterly undisturbed, breath may return in ragged snatches. But the spasms recur, triggered by the faintest stimulus, and each one arrests the breath again. Death, when it comes from asphyxia, or from the sheer exhaustion of muscles that cannot be told to rest. The body, in the end, killed by its own strength, spent against itself. So let us lay the two poles side by side, and let the symmetry become the thing that carries you down. Botulinum, no signal released, the muscle never told to move, death by silence. Curare, the signal released but never heard, the muscle deaf, death by silence. Strychnine, the stop signal never heard, the muscle told to move by everything and unable to stop, death by uproar. Too little, too much. And every one of them, every seal, every synapse, every channel, every brake, and every accelerator they seize, arrives at the same small, faithful muscle beneath your ribs. Every one of them ends the breath. From opposite directions, by opposite mechanisms, silencing and screaming, they converge on the diaphragm and they still it. That is what makes the neurotoxins, taken together, such a clean and complete lesson. There are only so many places to interrupt a movement. You can stop the transmitter from leaving. You can stop the transmitter from being heard. You can stop the inhibition from being heard and let the transmitter run without limit. Fill any of those doorways with the right molecule and you arrive, by a different path each time, at the same threshold. The body is a conversation of go and stop, spoken in acetylcholine and glycine, in sodium and chloride, in agonists that open channels and antagonists that block them. And a poison is only ever a molecule that has learned to sit in one of those doorways and refuse to move. We should pause before we climb on and set the ladder in order once more so that a drifting mind can find its footing. We began at the outermost edge where nerve meets muscle. We met botulinum, which severs the machinery inside the nerve ending so the signal never departs. We met curare, which crowds the muscle's own doorway so the signal, though sent, is never received. And tonight we have come inward, up the cord, to strychnine, which blocks not the message but the restraint upon it, and so kills by excitation without breaks. 3 poisons, 3 doorways, 1 ending, too little signal, too much. The breath, each time the breath. And notice how far we have already travelled inward. We began out at the surface of things, at the very periphery, at the 1,000th of an inch where a plant can interrupt your reaching hand. Now we stand deeper, in the cord itself, in the arithmetic of movement, in the balance of chloride and charge. And still we have not reached the center. There is further to go, past the nerve, past the switchboard, into the cell itself, into the small furnace where every one of these frantic muscles was drawing the energy to contract it all. Strychnine drove the muscles to exhaustion. But there are poisons that do not touch the nerve at all, that walk straight past the doorway, that reach instead for the fire inside each cell and put it out. That is where the night turns next. For now, let the symmetry hold you. Somewhere in your own spinal cord, at this very moment, Glycine is being released softly, faithfully, onto the motor neurons that would otherwise fire, and it is telling them, all of them, not yet, not now, rest. The murmur is being heard. Every muscle you are not using is being gently, chemically held still, so that you can lie here entirely at ease and do nothing at all. Feel it. The stillness you are sinking into is not the absence of signal. It is inhibition, working perfectly, a quiet chorus of not now, sung in the simplest molecule your body knows, holding you soft against the dark. Let it hold you. There is nothing you need to move. Nothing you need to stop. The break is faithful. The breath is your own. And when you are ready, we will follow the poison deeper still, past the nerve, past the muscle, all the way to the fire in the cell. There is a plant that grows in hedgerows and abandoned gardens, and its berries are glossy and dark and almost sweet. The Italians called it belladonna, the beautiful woman, and for centuries, women pressed its juice into their eyes to widen the black centers, to make themselves look softened and dreaming and open. They did not know they were reaching a molecule all the way down to the small ring of muscle around the pupil and quietly switching it off. They only knew they looked lovely and could not read a page held close, and sometimes, in high enough dose, began to see things that were not there. This is Atrapa belladonnac, deadly nightshade, and its cousins, staturac, the thornapple, and mandragorac, the mandrake of old herbals and older fears. They carry a family of alkaloids, and the two that matter most tonight are atropine and scopolamine. In the last chapters, we followed poisons that spoke to the nicotinic acetylcholine receptor, the fast gate of the muscle, the pentameric channel that Curare closes and nicotine flings open. Tonight we cross to the other branch of the same tree. Same neurotransmitter. Same messenger molecule, acetylcholine, released into the same synaptic cleft, but a different lock entirely. Because acetylcholine, that single small molecule your body trusts so completely, speaks to two great families of receptor. The nicotinic ones we have already met, ion channels, fast, twitch quick, at the skeletal muscle and the ganglia. And then there are the muscarinic ones, named for muscarine, a mushroom poison that mimics them. The muscarinic receptors are a slower, subtler class, not channels at all, but G-protein coupled receptors, 7 times threaded through the membrane, working 3-second messengers and cascades rather than a single open pore. 5 subtypes, from M1 to M5, scattered across the heart, the glands, the smooth muscle of the gut and bladder and eye, and threaded richly through the brain. These are the receptors of the parasympathetic nervous system, the rest and digest branch, the slow ballast of the body, the counterweight to fight and flight. And atropine and scopolamine are competitive antagonists at every one of them. Understand that word slowly, the way you are breathing slowly. They do not activate. They do not block a channel from the inside as Curare does. They simply arrive at the muscarinic receptor and sit in the seat meant for acetylcholine, occupying the binding pocket, fitting the shape, and doing nothing. The messenger arrives, finds its place already taken, and cannot deliver its message. Rest and digest goes silent. The parasympathetic brake, which we spent the last chapter admiring, is quietly lifted off the wheel. And when you lift that brake, the body does not fall still, it races. There is an old teaching rhyme, grim and sing-song, that medical students have recited for 100 years, and each line is a receptor being switched off. Hot as a hair. The muscarinic receptors on the sweat glands are blocked, so the body cannot sweat, cannot shed heat, and the temperature climbs, a hypothermia that in the fully poisoned can turn dangerous, the skin burning and dry. Blind as a bat. The M3 receptors on the ciliary muscle of the eye are blocked, so the lens cannot accommodate to focus on near objects, and the sphincter of the iris cannot constrict, so the pupil blows wide and stays wide, flooded with light, unable to read the page held close. Exactly the belladonna beauty, the dark and dreaming eye, rendered now as pathology. Dry as a bone. The glands fall silent, salivary, bronchial, lacrimal, sweat, the mouth parched, the eyes dry, the airways stripped of their protective film. red as a beet. The skin flushes, the vessels of the face dilating in the body scramble to dump the heat it can no longer sweat away, and mad as a hatter. Mad as a hatter because the muscarinic receptors are not only in the periphery, they are woven through the cortex and the hippocampus, where cholinergic signaling underwrites attention and memory and the ordinary continuity of thought. Block them there, and the mind comes loose from its moorings. This is not the dreamy sedation of the last poison. This is a florid, agitated, hallucinatory delirium, vivid, often terrifying, populated by figures and voices and impossible scenes, the person picking at the air, reaching for things no one else can see, unable afterward to remember any of it. Tetrodotoxin poisonings read like the same story told across every century and every continent, a person found in confusion, tearing at their clothes because the skin burns, seeing crowds where the room is empty. And in high enough dose, the heart racing unchecked and the temperature climbing and no water in the tissues to cool it, the delirium is not merely frightening, it can be the last thing. So hold the picture whole, because the whole picture is the mechanism, the racing heart, blockade of the M2 receptors in the sinoatrial node, the very receptors through which the vagus nerve normally slows the pulse, take away that slowing signal and the heart speeds. The blown pupils, the failure to focus, the dry mouth, the dry airways, the burning skin, the flush, the delirium. Every symptom is one branch of the parasympathetic nervous system going quiet at once. Everyone traces back to a single, elegant, terrible fact, a molecule from a berry, sitting patiently in the seat where acetylcholine was meant to sit, saying nothing at all. And now the turn. Because this is the double life spine of everything we are following through the long night. That a molecule is not good or evil, that dose and target and intention are what divide the poison from the cure, that the same key that locks a door in one room unlocks salvation in another. Nowhere is that turn cleaner than here. Because atropine, this delirium berry alkaloid, this widener of eyes and burner of skin, sits on the shelf of every crash cart and every ambulance in the world. It is a frontline emergency drug. When a heart slows too far, a dangerous bradycardia, the sinoatrial node firing too seldom, the pulse dropping towards standstill, the physician reaches for atropine and pushes it into the vein, and the very mechanism that made it a poison becomes the rescue. It blocks the M2 receptors at the node, lifts the vagal brake off the heart, and the rate climbs back up into safety. The racing heart of the poisoned man is, in a dying man, exactly the gift he needs. And there is a mirror to this, and the mirror is the most beautiful part. In the previous chapters, we watched what happens when acetylcholine floods the synapse. The nerve agents, the organophosphate pesticides, the compounds that poison acetylcholinesterase, the enzyme whose only job is to sweep acetylcholine out of the cleft. Poison that enzyme and acetylcholine piles up, unremoved, hammering every receptor without pause. A cholinergic storm, the exact opposite of tonight's poison. The victim drowns in their own secretions, streaming eyes, flooded airways, pinpoint pupils, the classic litany the toxicologists render as sludge secretion, salivation, lacrimation, urination, defecation, gastrointestinal cramping, emesis. Too much acetylcholine at the muscarinic receptors all at once. And what is the antidote to that storm? Atropine. The delirium berry poison, given by the syringeful, deliberately, to block the muscarinic receptors and shut out the flood. Where the last chapter's poison overwhelms the receptor with too much signal, this chapter's poison spares it by taking the seat. Two poisons, exact opposites, and one is the treatment for the other. A soldier exposed to a nerve agent is saved by an alkaloid from a plant that is killed by the hedgerow for 3,000 years. Hold that. Let it settle into the quiet. The poison is the antidote. The antidote is the poison. The molecule is neither. It is only a shape that fits a lock, and everything depends on which lock and how much and why. Scopolamine keeps its own gentler double life. It is the same competitive muscarinic antagonist, but it crosses more readily into the brain and it settles, in low dose, on a particular usefulness. There is a small adhesive patch worn behind the ear by sailors and cruise passengers and astronauts, and inside it is scopolamine, seeping slowly through the skin to hold off motion sickness. The nausea of the pitching deck is partly a cholinergic conversation between the vestibular system of the inner ear and the vomiting centers of the brainstem, muscarinic receptors passing the message of, "The world is moving wrongly, be sick." Block those receptors gently at the right small dose and the message never arrives. The sailor keeps his stomach. The molecule that in the S. datura seed conjures armies of phantoms, mated to a whisper and delivered through the skin over 3 days, simply lets a person watch the horizon rise and fall without fear. And behind the ear, the same molecule that killed by the roadside. In the eye, the same molecule that beautiful women once dripped to darken their gaze. For atropine is still used by ophthalmologists today, dilating the pupil so the retina can be seen, the vanity of the Renaissance turned into a tool of the clinic. Every use is one dose and one target away from the poison. Every poison is one dose and one target away from the use. This is the spine we have carried through the whole night, and it holds here as faithfully as anywhere. There is no clean line between medicine and murder in the molecule itself. The line is drawn by us, by the dose, by the tissue, by the intention. The berry does not know. The receptor does not care. Acetylcholine arrives, finds its seat taken, and simply waits. So let the picture blur softly at its edges now. Somewhere, a heart that had slowed toward stillness is climbing back to a safe and even rhythm because a physician gave it the exact poison the nightshade carries. Somewhere a sailor stands steady on a heaving deck because a whisper of scopolamine holds one small conversation quiet behind the ear. Somewhere, 400 years gone, a woman tilts her head back and lets a drop of belladonna widen her dark eyes, not knowing she has switched off the little muscle of her iris, not knowing the same reach could take her mind. And here you are, lying still, your own parasympathetic tone intact and unhurried, your pupils softening in the dark, your heart slowing gently the way it is meant to, at the edge of sleep, the vagus doing its quiet nightly work with no poison at all. Feel how ordinary and how astonishing that is. That right now, in you, acetylcholine is being released and received and swept away again and again, tens of thousands of times a second, at nicotinic gates and muscarinic seats, keeping your heart even and your breath slow, and your gut turning its slow work in the warm dark. And nothing is blocking it, nothing is flooding it, no berry, no patch, no syringe. The system is simply running as it was built to run, rest and digest, unopposed and unhurried, tilting you softly toward sleep. That is the whole of tonight's chapter, and you can let it go now, the way you let go of a word you no longer need to say. 2 receptor families, 1 messenger. The muscarinic seat and the 2 quiet antagonists that take it. Killers in the hedgerow, saviors in the crash cart. The same molecule wearing both faces at once, divided only by the dose. Hold it lightly. There is nothing to solve. And when you are ready, we will follow the poison further still, away from the nerve and its receptors, toward the poisons that do not speak to any receptor at all, but reach instead for the machinery deeper down, for the enzymes and the engines that keep the cell alive. Down here, beneath the receptors, beneath the tidy conversation of neurotransmitter and binding site, there is machinery that never rests. Every living cell you carry is, in a sense, a pump, a small, tireless engine bailing water against a leak that never closes. And tonight we descend to that engine, and to the poisons that jam it, and to the strange, beautiful truth that one of the deadliest of these is also one of the oldest medicines in the world. Let me show you the pump first, because everything that follows lives or dies by it. Inside every cell of your body sits a protein called the sodium-potassium ATPase, the NASIK ATPase, if you like the shorthand of the field. It is a membrane-spanning enzyme, and its job is deceptively simple. It grips 3 sodium ions from inside the cell and throws them out. It grabs 2 potassium ions from outside and hauls them in. 3 out, 2 in, and to do this, it burns 1 molecule of ATP each cycle. The cell's currency of energy, spent again and again, second after second in every cell, for the whole of your life. It is the single largest energy expenditure your resting body makes. A quarter or more of everything you eat, in some tissues, is burned just to run this one pump. Think of the cell as a boat with a slow leak. Sodium is the sea, always higher outside, always seeping in. Potassium is the fresh water you keep within. The pump is the sailor at the bilge, bailing without pause, keeping the sea out and the fresh water in. Sodium low inside, potassium high inside. A steep and deliberate imbalance held against the natural drift toward equality. This imbalance is not idle. It is a stored charge, a battery. It is the gradient your nerves discharge when they fire, the gradient your kidneys ride to reclaim salt, the gradient your gut uses to pull sugar from your food. The tide is held back on purpose. Everything you do spends the difference. Now imagine a molecule that reaches into that pump and freezes the sailor's hands. That molecule grows, quietly, in a garden. The foxglove, Digitalis purpurea, is a tall and stately thing, a spire of speckled bells in purple and cream, leaning over cottage paths and woodland edges across Europe. Bees crawl into its throats. Children have been warned away from it for centuries. Within its leaves, it manufactures a family of compounds called cardiac glycosides, digitoxin, digoxin, and their kin, molecules built of a steroid core fused to a lactone ring and hung with sugars, and this whole architecture exists, from the plant's point of view, for one purpose: to poison the animal that eats it. The oleander, Nerium oleander, that ornamental shrub of warm roadsides and Mediterranean gardens, makes its own version, oleandrin, by the same logic and to the same end: beautiful, ubiquitous, lethal in a mouthful. And what these molecules do is precise. They bind to the outer face of the NAR-SCI-AT pass, to a specific pocket on the pump, where potassium would normally dock, and they hold it fast. The sailor's hands stop. The bailing stops. Sodium, no longer thrown out, begins to rise inside the cell. The tide, held back so faithfully for so long, begins to creep over the deck. In most cells, this is simply damage. But in the muscle of the heart, something stranger and more consequential unfolds. And here is where the poison becomes, for a moment, a medicine. The heart has a second pump beside the first, a swinging door in the membrane called the sodium-calcium exchanger, the NCX. It trades sodium for calcium, and it runs on the very gradient the AT pars maintains. Normally, it uses the steep sodium in slope to shove calcium out of the cell after each beat, clearing the muscle so it can relax. But when the cardiac glycoside jams the ATPase and sodium rises inside, that slope flattens. The exchanger loses its driving force. It cannot pump calcium out as briskly as before, and so calcium accumulates inside the heart cell. And calcium is the trigger of contraction. Calcium is the spark that binds the muscle's filaments and pulls them past one another. More calcium inside the cell means each beat lands harder. The heart squeezes with more force. In a failing heart, a heart grown weak and dilated, a heart that can no longer clear the fluid pooling in the lungs, that extra force is not poison at all, it is rescue. This is why digoxin, a purified cardiac glycoside from foxglove, has been given to patients for more than 2 centuries, to strengthen a failing pump, and to slow the racing, chaotic rhythm of atrial fibrillation by acting on the vagus nerve and the conducting tissue between the heart's chambers. Poison and medicine, once again, are the same molecule. The only thing dividing them is the dose. And here, the dose is a razor's edge. Digoxin has what pharmacologists call a narrow therapeutic window, one of the narrowest of any drug still in common use. The concentration in the blood that helps is achingly close to the concentration that kills. A therapeutic level sits somewhere around half a nanogram to 2 nanograms in each milliliter of blood. Toxicity begins to appear not far above that. sometimes at levels that would have been fine in another patient on another day. There is almost no room. A little too much, a kidney that clears the drug more slowly than expected, a fall in the body's potassium. Because potassium and the glycoside compete for the very same seat on the pump, so when potassium drops, the poison binds more easily and its grip tightens without the dose changing at all, and the helpful becomes the harmful in silence. Say it slowly because it is the whole chapter in a sentence. Dose is everything here. The margin is a thread. And when that thread is crossed, by accident, by illness, or by intent, the same mechanism that strengthened the bait now destroys it. The calcium that made the muscle squeeze harder does not stop rising. Calcium overload floods the cell. The heart's electrical system, which depends on the orderly rise and fall of these very ions to time each beat, begins to misfire. The pump that was jammed lets sodium and calcium pool in defiance of the rhythm, and the cell begins to depolarize when it should be resting. Small, premature sparks that grow into full disorder. The chambers lose their conversation with one another. The steady drum becomes a tremor, and then a chaos, and then nothing. A fatal arrhythmia, born from the same tide, the same jammed sailor, the same overflowing deck. Only now there is no shore to bail toward at all. Every extra molecule of poison, every ion of potassium lost, every hour. The kidney fails to clear the drug. Every degree the margin narrows. All of it pushing the same pump, the same exchanger, the same overloaded cell toward the edge of its own rhythm. There is a story here, and it is one of the founding stories of everything we have been doing all night. The story of how we learned to tell dose from poison in the first place. In the county of Shropshire, in the England of the 18th century, there lived a physician named William Withering. In 1775, he learned of an old woman, a folk healer, who treated dropsy, the terrible swelling of the body that we now recognize as the fluid retention of heart failure, with a secret family recipe of some 20 herbs. Withering, with a botanist's eye, reasoned his way through the mixture and settled on the one that mattered, the foxglove. And then he did something that, for his age, was quietly revolutionary. He did not simply proclaim a cure. Over 10 years he treated 163 patients, and he wrote down what happened to each of them. He varied the preparation. He watched for the point where the good effect gave way to nausea, to disturbed vision, to a slowed and irregular pulse. The very signs, we now know, of the pump being pushed too far. He recorded his failures beside his successes. In 1785 he published it all in a slim book titled An Account of the Foxglove. That book is, by many reckonings, the birth of evidence-based pharmacology. Not the discovery that a plant could heal, people had known that for 10,000 years, but the discipline of measuring, of dosing, of watching for the edge and mapping it honestly. Withering could not have named the Nas Kaisi, A.T. Parse. He could not have drawn the sodium-calcium exchanger or spoken of nanograms in the blood. But he found the window by walking its edge with a careful pen, and he taught medicine to do the same. Every dosing chart since, every clinical trial, every narrow therapeutic range printed in a pharmacology text, descends in some quiet way from an old woman's garden remedy and a physician patient enough to count. Hold that gently as you drift. The same plant that taught us to measure poison is the plant that still requires the most careful measuring of all. There is one last thing to carry down into sleep, and it belongs to the shadow side of this molecule, to the forensic room where the dead are questioned. Cardiac glycosides are notoriously difficult poisons to detect. They act at nanogram concentrations, vanishingly small amounts, far below the reach of the crude screens that catch more common drugs. Digoxin can be measured because it is a medicine and laboratories are built to watch it. But the plant glycosides, oleandrin and its relatives, cross-react unpredictably with those tests, sometimes registering, sometimes hiding, mimicking a therapeutic dose or vanishing entirely. And the death they cause, a sudden, fatal arrhythmia in a heart that may already have been failing, looks, on the autopsy table, like so many ordinary deaths. A heart that simply stopped, No wound, no froth, no telltale color. Just the tide, come over the deck at last, and no obvious hand to blame. It is for these reasons that cardiac glycosides have appeared across the long history of poisoning as instruments, precisely because they are quiet, a killer that leaves the scene looking like nature. But do not let that darkness follow you down. Return, instead, to the pump. There it is, in every cell of you right now, working while you lie still. 3 sodium out, 2 potassium in, 1 molecule of ATP spent again and again and again. The tireless sailor at the bilge of every cell, holding the sea back from the fresh water, holding the charge that lets your nerves whisper and your heart keep its patient time. In the wall of your heart, the exchanger swings its door, calcium in and calcium out, each beat measured, each relaxation complete, the tide held exactly where it belongs. The foxglove in the hedgerow makes the molecule that would freeze all of this. And the physician, and the pharmacist, and the careful pen stand between the poison and the pump, measuring the thread. 2 engines, 1 gradient, a steroid ring with its cargo of sugars reaching into the pump to still it, a mouthful of ruin, a milligram of rescue, the whole difference held in the narrowest window in all of medicine, Withering counting his patients by candlelight. The tide held back on purpose in every cell you have. Nothing to solve tonight, only the pump and its faithful work going on beneath everything while you rest. And when you are ready, we will leave the heart and its pump behind and follow the poison deeper still, down past the membrane, into the furnace of the cell itself, to the poisons that do not jam a pump but smother the fire that powers all the pumps at once. Down past the membrane then, into the quietest room the cell keeps, not the wall where the channels sit, not the surface studded with its receptors, but the deep interior where the work itself is done. Every poison we have followed so far has spoken to a lock. It has fitted a receptor, jammed a pump, opened a gate, silenced a nerve. It has been a conversation, however cruel, a molecule saying something false to a listening protein. But the two poisons of this chapter do not speak to a lock at all. They walk past every lock, past every listening thing, and they go instead to the place where the cell builds itself. They shut down the factory. And here is the forensic through line we have carried all night, restated once more in its darkest form. The poison is not the wound, the poison is the message. And these two carry the one message: a cell cannot survive hearing, which is the instruction to stop making itself. Consider first the castor bean, a Ricinus communis, an ornamental thing with leaves like spread hands, grown in gardens the world over. Inside its seed sits ricin, and ricin is not a small molecule at all. It is a protein, 2 chains, an A chain and a B chain, bound together like a key wired to the hand that turns it. The B chain is the hand. It binds to galactose sugars that stud the outside of nearly every cell in your body, and once it has taken hold, the whole assembly is drawn inward, swallowed by the membrane into a bubble called an endosome, carried backward through the cell's own delivery system toward its interior. This is the terrible elegance of it. The cell does the smuggling. The cell opens its own door and reaches out and pulls the poison in, mistaking the hand for a friend. And when the 2 chains part inside, when the A chain slips free and finds its target, it goes to the ribosome. The ribosome is the factory floor of every living cell, the machine that reads messenger RNA and stitches amino acids into protein one after another, the loom on which the whole fabric of you is continuously rewoven. The large half of that machine, the 60S subunit, holds a strand of ribosomal RNA called the 28S, and buried in it is a single adenine base at a single position, one letter in a text millions of letters long. The ricin. A chain is an enzyme, and it has exactly one thing it knows how to do. It reaches into that spot and it cleaves that one adenine away. Depurination, the chemists call it. It removes a single purine base from a single site, and that is enough. That one snipped letter cripples the ribosome's ability to bind the factors that retch at the machine forward, and the loom seizes. No more protein, Here is what should make you breathe slowly with the strangeness of it. 1 molecule of ricin. A chain does not die after its work. It is a catalyst. It moves to the next ribosome and depurinates that one and the next at a rate of well over 1,000 ribosomes a minute. A single molecule, given time, can silence the entire manufacturing capacity of a cell. This is why the lethal dose is so vanishingly small, micrograms, a speck, a thing you could not see. Not because ricin is loud, but because it is patient, and it works one machine at a time tirelessly, and there is no counter-message to send. And now the delay, the signature that ties every protein synthesis poison together. When you jam a sodium channel, the nerve falls silent in seconds because the channel was doing its work moment to moment. But a cell does not die the instant its ribosomes stop. It dies when it runs out of the proteins it already has, the enzymes that wear out and are not replaced, the structural parts that fray and are not rebuilt, the membrane pumps that break and leave no successor. So the poison strikes in silence. Ricin gives you hours, sometimes the better part of a day, of feeling almost nothing wrong or only a vague unease, while inside every exposed cell the looms have already stopped and the countdown has already begun. Then the failure arrives all at once as the stockpiles run dry and the gut and the liver and the vascular lining come apart in sequence, a collapse whose seed was planted long before the first symptom. Georgy Markov knew none of this on a London bridge in 1978. A Bulgarian writer, a dissident, waiting at a bus stop, he felt a sting in the back of his thigh and turned to see a man stooping to pick up a dropped umbrella. He thought nothing of it. That is the whole horror of the delay, held in a single afternoon. A tiny metal pellet, drilled with 2 crossed holes and packed with a fraction of a milligram of ricin, sealed with a wax meant to melt at body temperature, had been fired into his leg. For hours he was fine. That evening, a fever. The next day, the collapse. 3 days after the bus stop, he was dead, and the pellet was found only at autopsy, its holes emptied, its cargo long since delivered to the factory floors of his cells. No antidote existed then. None truly exists now. Once the hand has pulled the poison in, the letter is already gone. Now cross from the garden to the forest floor, from a manufactured protein to a wild one, and meet the poison that has killed more people than any mushroom on earth. Amanita phalloides sash, the death cap. It is not garish, it does not warn. It is pale green to olive, unassuming, and it has been mistaken for edible mushrooms across every continent it grows on. It carries a family of poisons called the amatoxins, and chief among them is cis-amanitin. And here too, the target is the factory, but a different room of it. If the ribosome is the loom, then the messenger RNA is the pattern the loom reads, and that pattern must be written before it can be read. It is written by an enzyme called RNA polymerase II, which crawls along the DNA in the nucleus, transcribing gene after gene into the messenger strands that will be carried out to the ribosomes. This is the step before the step. This is the drafting of the instructions. And phatromenitin binds to RNA polymerase II, not to its active site, but to a hinge called the bridge helix, the moving part that levers the enzyme forward one base at a time. With the amatoxin lodged there, the polymerase can still bind DNA, can still hold its place, but it cannot translocate. It cannot take the next step. It stalls mid-sentence and the writing stops. No new messenger RNA. And so downstream, no new protein either, the same silence as ricin, reached by shutting the room upstream instead. The pharmacokinetics of the death cap are a lesson in why delay is deadlier than speed. When you eat the mushroom, the amatoxins are absorbed from the gut and carried by the portal vein straight to the liver, first pass, before they reach the rest of the body. The liver cell has a transporter on its surface, one that normally hauls bile salts inward, and this transporter, by an accident of shape, also hauls amatoxin inward. So the liver concentrates the very poison that will destroy it, pulling it in through its own honest machinery. And it does not merely pass through once. Amatoxin is excreted into the bile, sent back down into the gut, and reabsorbed again, a cycle called enterohepatic recirculation that keeps the poison sluicing through the liver again and again, dose after dose delivered to the same doomed cells, so that the total exposure of the liver far exceeds the mouthful that was swallowed. And then the deception, which is the cruelest of all the delays we have named tonight. For 6 to 12 hours after the meal, nothing. Then a violent gastrointestinal storm, vomiting, cramping, watery diarrhea, severe enough to send a person to a hospital. And then, on the second day, it eases. The storm passes. The patient feels better. This is the false dawn, the deceptive day of apparent recovery, and it has killed more people than any single symptom, because it looks like the crisis is over. Sometimes a patient is even sent home. But beneath the calm, the polymerases in the liver cells have been stalled the whole time, and the hepatocytes, unable to replace the proteins they spend, are beginning to die. On the third and fourth day, the liver fails outright, and the kidneys behind it, and what looked like recovery reveals itself as the eye of the storm. Every year, across Europe and North America and Asia, foragers who trusted a pale, unassuming cap arrive at this false dawn, and some of them do not leave it. Hold the two poisons side by side and hear how the same message is spoken twice in different tongues. Ricin depurinates the 28S ribosomal RNA and disables the loom. Amanitin binds the bridge helix of RNA polymerase II and freezes the writing of the pattern. One stops the reading, one stops the writing, and both arrive at the identical ending. A cell that cannot renew itself, running out its stores in silence, failing not at the moment of the poison, but hours or days later when the shelves go bare. Both concentrate in the liver, that patient organ that filters everything and pays for its diligence. Both wear the mask of a delay. Both are catalysts or near catalysts, tiny amounts doing enormous work. One molecule silencing machine after machine while you feel almost nothing wrong. And so the forensic through line turns once more, restated in its most unsettling form yet. All night we have said the poison is not the wound, but the message. The molecule that fits a receptor, jams a pump, opens a gate. But a message needs a listener, and a receptor can be blocked, a channel can be reopened, a conversation can be interrupted if you are fast enough. These two poisons are worse precisely because they do not talk to a listener you can protect. They walk into the room where the cell speaks to itself, where it writes and reads its own instructions for staying alive, and they silence that voice. There is no antagonist for the death cap because there is no receptor to compete for. There is no reversal for ricin because the letter, once cut, is gone. The only medicine is time bought before the shelves run empty, a transplanted liver in the worst cases, an entire organ replaced because its factory has been switched off from within. Let the delay itself become the image you carry down into sleep. Not a strike, not a seizure, not a scream of the nerves, but a quiet room in which the writing has already stopped and no one has noticed yet. The machine standing still while the shelves are still full, the failure already certain and still hours away. Georgy Markov, turning at a bus stop toward a man and an umbrella, feeling nothing worth remembering. A forager admiring a pale green cap on a forest floor. The stillness before, which is not safety, only the interval. The symptom-free window in which the countdown has already begun and the day still seems ordinary. And your own cells right now, in the dark, doing the opposite of all this. Your ribosomes reading, your RNA polymerases writing, 10,000 looms in every cell weaving protein without pause, replacing what wears out before it fails, so quietly you have never once felt it. The factory that never closes. The renewal you never notice because it never stops. Nothing to solve tonight. Only the writing and the reading going on beneath everything, faithful, unhurried while you rest. And when you are ready, we will leave the factory floor behind and follow the poison to a stranger place still, to the toxins that do not shut the machine down but seize it and hold it open, the ones that will not let the nerve fall silent, the ones that turn a single signal into a storm that never ends. There is a poison that lets you keep breathing while it kills you. The lungs still rise and fall. The heart still moves the blood along its circuit. The chest does everything it has always done, faithfully, in the dark. And yet, deep inside every cell, something has gone quiet that was never meant to go quiet, and the body begins to suffocate in a room full of air. This is cyanide. And to understand it, we have to go down, past the skin and the muscle, past the blood vessels, all the way to the small dark engines inside your cells, the mitochondria, where breathing actually means something. Because breathing, the real breathing, is not the air moving in your chest. That is only the delivery. The true reason you draw breath is a single molecule, oxygen. And the true reason your body wants oxygen is a place at the very end of a long chain, a place where oxygen is finally allowed to do the one thing it was brought all this way to do. Let me show you that chain, slowly, the way you would trace a river to its mouth. Inside each mitochondrion runs a line of proteins embedded in a folded inner membrane, and we call it the electron transport chain. Picture a series of water wheels set along a stream, each one turning as the water falls past it. The water here is electrons, small parcels of energy stripped from the food you ate, carried in on molecules called NADH and FADH and FADH2, the tired remnants of sugar and fat. They arrive at complex 1 and complex 2, and they begin to fall. They fall through complex I. They fall to a small mobile carrier called coenzyme Q. They fall to complex 3. They fall to another shuttle, cytochrome C, a little protein that ferries a single electron at a time across the membrane's face. And at each fall, at each turning wheel, the energy released is used to pump protons, hydrogen ions, out across the membrane, building a reservoir, a charged gradient, a kind of dammed lake of potential pressed against a wall. And that lake does the final work. The protons flood back through a spinning molecular turbine, ATP synthase, and their return turns the rotor, and the rotor stitches together the body's true currency, ATP, adenosine triphosphate. The molecule you spend on every heartbeat, every thought, every closing of your eyes. This is oxidative phosphorylation. This is what breathing is for. But the electrons cannot simply pile up at the bottom of the stream. Something has to receive them at the very end, or the whole chain backs up and stops, like water rising behind a wheel that will no longer turn. And the receiver, the final catcher, is a single enzyme, complex IV. Cytochrome C oxidase. It takes 4 electrons, and it takes oxygen, the oxygen you breathed in, and it joins them with hydrogen to make water. Gentle, ordinary water. That is the destiny of every breath. Oxygen exists in your cells to stand at the end of the line and accept what falls. Now understand what cyanide does. Cyanide, the ion, C in G, slips into that final enzyme and binds to the iron atom at its heart, the ferric ion in the heme of cytochrome C oxidase. It sits precisely where oxygen was meant to sit, and it does not let go. The catcher is chained. Oxygen arrives and finds the seat taken. So the chain backs up. The electrons cannot fall. The water wheels stop turning. The protons stop being pumped. The lake drains and is not refilled, and ATP synthase slows and stalls. Within moments, the cell can no longer make ATP by the efficient path, and it is thrown back onto the desperate, wasteful emergency of anaerobic metabolism, burning glucose without oxygen and pouring out lactic acid as it does. The blood turns acidic, the tissues starve. And here is the cruelty, the thing that makes cyanide feel like a paradox. The oxygen is still there, the lungs are still delivering it, the blood is still carrying it, bound to hemoglobin, bright and red and full. It cannot be used. A cyanide victim's blood stays a vivid arterial red, even in the veins, because the tissues never drew the oxygen out. They could not. The body is drowning at a banquet. Suffocating in a room full of air. The organs that fail first are the ones that spend the most, the brain and the heart, the two most metabolically hungry tissues you own, the two that cannot coast on stored ATP for more than seconds. This is why death by cyanide is fast. A large, inhaled or ingested dose can drop a person in minutes, First headache and dizziness and a racing heart as the body senses it is starving, then confusion, seizures, collapse of breathing as the brainstem itself runs out of fuel. Minutes, sometimes less. The dose again decides everything. A lethal oral dose of a cyanide salt is only around 200 to 300 milligrams, a fraction of a teaspoon. But cyanide does not only come in bottles marked with skulls. It hides in the ordinary, in the botanical, in fruit. There is a family of plant compounds called cyanogenic glycosides, molecules that carry cyanide folded up inside them, harmless as long as they stay folded, sugar-linked and quiet. The most famous is amygdalin, and it lives in the seeds of the rose family, the kernel inside a bitter almond, the pips of apples, the pits of cherries and apricots and peaches and plums. It lives, too, in cassava root, the staple that feeds hundreds of millions across the tropics. The folded molecule is not the danger. The danger is the unfolding. When plant tissue is crushed, chewed, ground, bruised, a plant enzyme meets the glycoside and cleaves it, and the sugar comes off, and the molecule collapses toward its poison, releasing hydrogen cyanide. So, a whole apple's worth of seeds, swallowed whole, passes through you nearly untouched, still folded. But the same seeds chewed thoroughly begin to release their cyanide in your gut. Bitter almonds are bitter precisely because of amygdalin. A handful of them can carry a meaningful dose, which is why the sweet almond you eat by the bowlful is a different, bred for cultivar, low in the glycoside. And cassava, eaten without the long soaking and fermenting and drying that traditional preparation demands, has caused mass poisonings and a crippling paralysis called konzo, where hunger forced shortcuts. The knowledge of how to unfold the poison safely, to leach it away before it reaches the enzyme in your cells, is knowledge measured in generations. And yet, here is the mercy folded into the biology. You meet tiny traces of cyanide often, and you survive them because your body has quietly been carrying an antidote all along. The enzyme is called rhodonase, and it lives mostly in your liver and kidneys. Slowly, patiently, it takes cyanide and joins it to a sulfur atom, converting it into thiocyanate, a far less toxic molecule that your kidneys can simply wash away in the urine. This is why the seed of one apple is a story and not a funeral. It is why trace cyanide in ordinary food, in the smoke of a fire, even in the small amounts your own cells produce, is handled without your ever noticing. It is the dose, always the dose. A little cyanide is a task for a Sunday slow enzyme. A lot of cyanide arrives faster than rhodonase can possibly work, and the enzyme, overwhelmed, is left behind while the poison reaches the mitochondria first. So the antidotes we have built for emergencies do the same thing rhodonase does, only faster and by different routes. And understanding them is understanding the poison in reverse. The first strategy is to give the body more of what it needs and pull the cyanide off its enzyme. Hydroxycobalamin, a form of vitamin B12, dark red, given by infusion, carries a cobalt atom at its center, and cyanide is drawn to that cobalt with great affinity. The cyanide leaves the ion of cytochrome C oxidase and binds the cobalt instead, forming cyanocobalamin, which is simply another, harmless form of B12, and out it goes in the urine. It is a chemical decoy, a place more tempting than the enzyme, offered in a flood large enough to draw the poison away. The catcher is unchained. The water wheels can turn again. The second, older strategy is stranger, and it works by sacrifice. Nitrites, amyl nitrite breathed in, sodium nitrite in the vein, deliberately damage some of your hemoglobin, oxidizing its iron to make a form called methemoglobin. Methemoglobin cannot carry oxygen, which sounds like a wound, and it is one, but methemoglobin's iron binds cyanide even more eagerly than cytochrome C oxidase does. So you create, on purpose, a sink in the bloodstream, a great crowd of iron atoms begging for the cyanide. And the poison is pulled out of the mitochondria and held in the blood instead, where it can do no harm to the engines. Then a dose of sodium thiosulfate is given, sulfur handed directly to rhodonase, feeding the natural enzyme the raw material it needs to finish the job and turn the captured cyanide into thiocyanate for good. pull the poison off the enzyme, offer it a decoy it likes better, feed the sulfur that carries it away. 3 doors, 1 truth. Cyanide kills by holding the last enzyme shut, and every antidote is a way of opening it back up before the brain and the heart run out of ATP. There is a weight to this molecule that goes beyond the biology, a shadow it casts through history that few poisons match. Cyanide is fast, and it was terribly available, and so it became the poison of spies and executions and the darkest chapters of the last century. The substance in the capsule, the substance in the gas, a word that carries dread all on its own. In the forensic world, it leaves signs the trained eye can read, that unnaturally bright red blood in the tissues, the faint smell of bitter almonds that only some people are genetically able to detect at all, the acid in the blood, the ATP that simply stopped being made. It is one of the few poisons whose mechanism is so clean, so singular, that you can name the exact enzyme, the exact ion atom, the exact seat that was taken. And so we return, as we always do, to the quiet center of it. Cyanide does not tear anything. It does not burn or dissolve or bleed. It simply sits down in a single chair, at the very end of the electron transport chain, in the last enzyme of complex IV, and refuses to move. And because that one seat was meant for oxygen, and oxygen alone, the whole vast machinery of breathing is undone from its smallest point. The lungs move air over a body that can no longer use it. The blood runs red with oxygen no cell can spend. The body suffocates without ever losing its breath. And in that same body, all through an ordinary quiet day, cytochrome C oxidase catches oxygen billions upon billions of times without a single failure, joining it to hydrogen, making water, letting the electrons fall and the protons flood, and the turbine turn, spinning out the ATP that lets you lie here now, warm and unhurried, thinking of nothing you must fix. Rhodonese keeps its slow watch in the liver, taking the little traces of poison the world hands you and carrying them harmlessly away, and you never feel the work of it, and you never have to. Nothing to solve tonight. Only the last enzyme in the chain, turning oxygen into water over and over, faithfully, while you rest. And when you are ready, we will follow the poison inward once more to the toxins that do not stop a single enzyme but confuse the very language of the blood, the ones that keep the body from carrying oxygen at all, or that take the place of oxygen and will not be dislodged, the quiet impostors that slip into hemoglobin itself. There is a poison that does not choose a single door. Almost everything we have followed through this long night has been a key, a molecule shaped to fit one lock and turn it. Curare fits the nicotinic receptor. Atropine blocks the muscarinic one. The opioids settle into the mu-opioid receptor as if it were carved for them. Tetrodotoxin plugs the voltage-gated sodium channel and nothing else. These are precise poisons, elegant almost, and their precision is why they act so fast. A single target, one turn of one lock, and the body falls. But arsenic is not a key. Arsenic is rust. Consider how it enters. Arsenic is not built by any plant or animal. It is an element drawn up out of rock and water, older than life, indifferent to it. And when it comes in, dissolved in a glass, ground fine into a powder, folded into food where it has almost no taste, it does not seek out one receptor and wait. It scatters. It disperses through the blood and into every tissue, and it begins, quietly, to bind to a chemical feature that is not special at all, a feature repeated thousands upon thousands of times across the machinery of the cell. That feature is the thiol group, the sulfhydryl, 2 atoms, a sulfur bound to a hydrogen, hanging off the amino acid cysteine, and cysteine is everywhere. It sits in the folded hearts of enzymes, holding their shapes, forming the little bridges that let proteins do their work. Wherever a thiol group is exposed, arsenite, the trivalent form of arsenic, reaches out and grips it. Sulfur has a deep chemical fondness for the soft metals, and arsenic exploits that fondness ruthlessly, clamping onto the thiols, and where it clamps 2 of them close together, it locks them, binding both at once like a hand closing over 2 threads and pulling them still. And so the poison is broad and slow and everywhere. Now follow it to where the damage matters most. Deep in the mitochondria, at the entrance to the citric acid cycle, sits an enzyme called pyruvate dehydrogenase. Its job is the hinge of your whole metabolism. It takes pyruvate, the end product of breaking down sugar, and converts it into acetyl-CoA, the fuel that feeds the cycle that ultimately turns oxygen into energy. And pyruvate dehydrogenase does this with the help of a small molecule called lipoic acid, which carries, of all things, two thiol groups sitting close together, side by side. Two thiols, side by side. Arsenite could not have designed a better handhold. The arsenic bridges them, binds both, and the enzyme freezes. Pyruvate piles up. The gate to the citric acid cycle swings shut. And the cell, still holding sugar, still holding oxygen, still surrounded by everything it needs, begins to starve. Not for lack of fuel, but because the machine that burns the fuel has seized. This is the cruelty of it. The lights are on, the pantry is full, and the furnace will not light. But arsenic has a second trick, and it works by imitation. There is another form, arsenate, the pentavalent form, and arsenate is a mimic. In shape and charge it looks very much like phosphate, the humble ion the cell uses everywhere to store and move energy. Adenosine triphosphate, ATP, is nothing but adenosine wearing three phosphates in a row, and the last two bonds between those phosphates are where the cell keeps its usable energy, coiled like a spring. When the cell builds ATP, it reaches for phosphate. And in the confusion, it sometimes reaches for arsenate instead, and slots it into the chain. But the arsenate bond will not hold. It hydrolyzes, falls apart, almost as soon as it forms. The spring is never coiled. Energy that should have been captured leaks away as heat and nothing. Biochemists call this arsenolysis, the futile substitution, the counterfeit coin that dissolves in the hand. So arsenic attacks energy from both sides at once. Arsenite jams the furnace. Arsenite empties the vault. And every tissue that lives on ATP, which is every tissue you have, begins slowly to fail. Slowly. That word is the whole history of this poison. A curare death is minutes. A tetrodotoxin death is hours, but arsenic, taken in small amounts over days and weeks, produces something that does not look like poisoning at all. Vomiting, cramping, weakness, a wasting that comes and goes. It looks like dysentery. It looks like a slow illness, a failing constitution, a body simply giving out. And because it accumulates, because each dose adds to the last, binding a few more thousand thiols, seizing a few more enzymes, and because arsenic lingers in the tissues, in the hair, in the nails, the poisoner does not need a single dramatic dose. They need only patience. This is why, for centuries, arsenic was called the inheritance powder. Hear the whole thing in that phrase. A wealthy relative sickens slowly across a season, declines as the elderly and the inconvenient are expected to decline, and dies, and the estate passes on, and no one asks the powder any questions. It was the poison of quiet ambition, of the long game, precisely because its mechanism is diffuse. There is no single lesion to find, no one receptor blockaded, no telltale paralysis. Just thousands of small failures spread across every organ, wearing the mask of ordinary death. And it kept that mask until chemistry learned to lift it. In 1836, an English chemist named James Marsh built a test, the Marsh test, that could take a sample of tissue or stomach or fluid, treat it with zinc and acid, and coax any arsenic present into a gas, arsine, which, passed through a heated tube, would deposit a bright metallic mirror of pure arsenic on cold glass. A silver-black stain, visible to the eye, from a quantity far too small to taste or see in the body. And for the first time the diffuse poison had a signature, the inheritance powder had a fingerprint. Forensic toxicology, the whole science of proving that a death was a poisoning, was born, in a very real sense, out of the need to catch arsenic. The rust that hid in everything was finally made to shine. And here we should pause, because arsenic gives us the last shape in our taxonomy of poisons, and it is worth holding all the shapes together one final time before the night closes. Think back over the whole ladder. We began with the poisons that speak to receptors, the mimics and the blockers. The ones that pretend to be a neurotransmitter and turn the switch on, nicotine at the nicotinic receptor, muscarine at the muscarinic one. The ones that sit in the switch and jam it shut, curare, atropine, the whole family of antagonists. We climb to the poisons that inhibit the enzymes, the organophosphates and the physostigmine-like compounds that block acetylcholinesterase and let the signal drown in its own excess, and just now, cyanide, freezing the last enzyme in the respiratory chain so oxygen can no longer be spent. We pass through the poisons that seize the ion channels directly, Tetrodotoxin and saxitoxin closing the sodium gate, Batrachotoxin wedging it open, the scorpion and the sea, each rewriting the electrical alphabet of the nerve. We touched the imposters of the blood, the ones that take the place of oxygen in hemoglobin and will not leave. And now, at the end, arsenic, not a key at all, but a corrosion, binding not one target, but a chemical feature repeated 10,000 times, crippling metabolism everywhere at once, slow and broad and cumulative, the poison of erosion rather than the poison of the single struck blow. Receptor, enzyme, channel, carrier, corrosion. That is the whole grammar of natural poison. Every toxin we have named tonight is a sentence built from those few words. And it is right, I think, to close the way we opened, with a man drinking a cup in a stone room. Socrates, in 399 before the Common Era, condemned by Athens, handed a cup of hemlock and told to walk until his legs grew heavy. Hemlock, the plant Conium maculatum, carries an alkaloid called coniine, and coniine belongs, in its way, to the very first chapter of everything we have said. It acts at the nicotinic acetylcholine receptor, the same receptor Curare blocks, the same one nicotine overstimulates. Coniine floods it, first exciting and then, through relentless depolarization, blocking the neuromuscular junction. And it meddles too at the sodium channels of the nerve, so that the message from brain to muscle simply cannot arrive. And the death it gives is the one his students recorded, a slow ascending paralysis, beginning in the feet and climbing, the chill moving up the legs, the numbness reaching the waist, the chest. His mind, they said, stayed clear to the end, because coniine spares the brain and takes only the muscles, until it reached the diaphragm, and the diaphragm, which is only a muscle, could no longer be told to move, the neuromuscular junction silenced. The same junction curare silences from the other side of the same door. So the whole night bends back on itself. The first poison and the last are speaking to the same receptor. The oldest recorded execution in the West and the newest molecule pulled from a rock share a single sentence in the grammar of the body, the sentence that says, quietly, this message will not be delivered. That is the thing to carry down into sleep. That poison is not magic and not malice. It is only chemistry finding the shapes that were already there. Every receptor a poison fills was built to be filled by something gentler. Every enzyme a poison freezes was meant to turn. Every channel it jams was already opening and closing 10,000 times a second inside you, faithfully, as it is doing now. And most of them, tonight, are simply doing their work. Your acetylcholinesterase is clearing each signal the instant it is sent. Your cytochrome C oxidase is handing electrons to oxygen at the end of the chain, making water, making energy, in the dark, warm rooms of every cell. Your pyruvate dehydrogenase is opening the gate to the cycle, its little paired thiols untouched, unbound, free, no arsenic on them tonight, no rust. There is nothing to solve. There is nothing to decide. The whole vast alphabet of poison exists, and none of it is being spoken in you right now. Only the ordinary, endless, unpoisoned sentence of a body keeping itself alive while you rest. Let your shoulders soften. Let the breath go slow. Feel it come in, and feel the enzymes take the oxygen, quietly, the way they have all your life. Nothing is climbing your legs. Nothing is closing the gate. There is only the warmth and the dark and the faithful chemistry, turning, 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 asking nothing of you now. Sleep well, and good night. So let us gather all of it one last time and let it settle. Nature has built a molecule for nearly every point of failure in the body. A channel jammed, Batrachotoxin holding the sodium gate open, a channel welded shut, Tetrodotoxin plugging it closed. A signal never sent, botulinum toxin cleaving the SNARE proteins so acetylcholine can never leave the nerve. A signal never heard, Curare sitting on the nicotinic receptor where acetylcholine should land. A brake released, strychnine blocking glycine until every muscle fires at once. A pump stalled, a factory shut, a cell suffocated. Cyanide clasped to cytochrome C oxidase so the mitochondria cannot breathe. And yet, the line between poison and medicine was only ever the dose, the delivery, the affinity, nothing more. These molecules were never designed to kill you. They are old, older than us by hundreds of millions of years. Chemical negotiations between organisms, defenses and lures and warnings, perfected long before anyone was here to be poisoned by them. We only learned, late and slowly, to read them, to fear them, and then, gently, to tame a few, botulinum in a syringe, smoothing a brow, digitalis, steadying a failing heart, atropine, waiting in the crash cart, curare, holding the body still while a surgeon works. The venom and the cure are the same word, spoken at a different volume. And right now, in you, all of that machinery is running. Your sodium channels are opening and closing tens of thousands of times without a single error. Acetylcholine is crossing 1,000 quiet gaps and being swept away again by its enzyme. The sodium-potassium pump is turning, 3 out, 2 in, spending its ATP without complaint. Your mitochondria are breathing oxygen into energy, cytochrome by cytochrome, clean and unbound. Every target, every gate, every pump, untouched, working. The same chemistry that could end a life is the chemistry keeping yours going tonight, unbidden, while you do nothing at all. So let it keep working. Let the channels open and close. Let the pump turn. Let the breath come slow. There is nothing to hold, nothing to guard, nothing to decide. Only the faithful chemistry, turning in the dark. Sleep well, and good night.